Hi, welcome to another video on trial and improvement this time. If you want to pause the video now and take down these notes, that way you can at least kind of relax and focus on what's happening in the maths, maybe take down some of the things that we do as we do it. At any time during the video, please feel free to pause, you can rewind, you can watch something if you haven't understood it for the first time, you can watch it again and again until you do. Alright, so I'm assuming that you have paused it and that we are on the same page here. Okay, so let's begin. If in a non-calculator paper you get this sort of question, root 16 equals what? What they're actually asking here is x square rooted equals 16. In other words, what number times by itself is going to give me 16? Likewise, if you give root 9, that's saying x squared equals 9. In other words, what squared is going to give me 9? Now these are pretty easy. In both of these I can say x is equal to 4, and in this one I can say x is equal to 3, assuming I only take the positive, because obviously I could say negative 4 times negative 4 is 16. But when we're dealing with that, we're assuming it's a positive root. Okay, so if we're right with that, it gets a little bit difficult where if in a non-calculated paper they give us something like this, x squared, instead of equaling a nice square number there, we end up with x squared equals, say, 14. Now in a calculated paper, that's easy. You just bang in the square root of 14 and you get an answer out. But in a non-calculated paper, that's actually a little bit challenging. And so we have a method that we use called trial and improvement. And it's basically, you guess. Right? But you don't just guess randomly. You don't go, all right, let's try 100. 100 squared, oh, okay, 10,000, okay, well, let's try something else. Let's try 57. It's not random. It's you trial something and then you improve upon it. You do something to make it better. Alright, so in this case, I can probably guess where about this is going to lie. I can say, well, I know that the square root of 16 is 4, and I know that the square root of 9 is 3. So my answer, 14, is going to sit, because root 14 sits between 16 and 9, so it's going to sit between 4 and 3. Alright, so let's do this. The first thing we do is we've got to establish where it's going to sit. So I need to start a table. So what am I actually going to trial? What am I putting in as x? Right, so I'm going to start off by putting in 3. Right, so what's my working? What's actually going to happen here? Well, I'm just going to go 3 squared. 3 squared is 9. And now, because I want to improve upon that, I have to comment. I have to look at this and say, all right, well, 3 squared equals 9. 9 is not the number. 9 is actually too small. 9 is too small for me. All right, cool. Now I can improve upon that. Well, if that's too small, let's try something bigger. So let's try 4. I know that 4 squared is 16. And I know that 16 is actually too big, because what I wanted to get out was 14. All right, brilliant. So now I can use these and say, all right, well, I've got to pick a number that's between 3 and 4. And I'm not just going to randomly guess a number that's between 3 and 4, so I'm not going to pick like 3.1972. I'm going to pick intelligently. I'm going to try and improve what I've been doing here. All right, so between 3 and 4, if we pick a random number, let's say 3.9. And I've chosen 3.9 because my answer my answer 4 gets me 16, or my trial of 4 gets me 16, and 16 is close to what I want to get. So if we try 3.9, I end up with 3.9 squared is going to give me 15.21. Now I have trialed this already, but you would literally just punch that into a calculator. And this, by the way, this question would appear in a calculator paper, but it would specifically say using trial and improvement. Or it would be nice, easy numbers that we could actually work. If you wanted to do 3.9 squared, you could literally just do 3.9 times 3.9, however you want to. You know, you do 39 times 39 and put in the decimals, whichever method you prefer. All right, so now I get 15.21. 15.21, that's again too big. Okay, so let's be a bit more intelligent. Let's try 3.8, because that's pretty close. We're getting there. 3.8 gives us 14.44. If I do 3.8 squared. Okay, so 3.8 squared and 14.44. Unfortunately, that's still too big. Okay, well, that's 3.7. And 3.7 actually gives me 13.69. 13.69, that's now too small. Okay, I'm going to stop there, because if I carried on 3.6 and 3.5, 3.4, I'd just be getting smaller and smaller. I know that my answer is going to sit somewhere between 3.8 and 3.7. Alright, so let's try between 3.8 and 3.7. And if we try, let's just try 3.75. And if we try 3.75, we do 3.75 squared, end up with 14.06. And that is too big, but it's really, really close. Now, I could continue on and on and on. I could then try 13.76. That would probably be, 13.74, that would be too small. And then I could try 13.752, and on and on and on and on. And in fact, it would actually be limitless, because if I actually do the square root of 14 square rooted, I end up with 3.74165738. Now, to do trial improvement all the way down to that level isn't really feasible, which is why we are always given in a trial improvement question, I am told I want this to a limit. In other words, to 1 decimal place. So we have to pay attention to that. Okay? We have to pay attention to the 1 decimal place. And what that means is that my answer is either going to be 3.8 or it's going to be 3.7. I'm not going to worry about this 3.75 because it's got 2 decimal places. I am going to use it, however, because my answer, we've already said, is going to sit somewhere between 3.7 and 3.8. Whereabout is it going to sit, though? Right? Is it going to be close to 3.7 or is it going to be close to 3.8? In order to find that, I use 3.75. Right? 3.7 we established was too small, we established 3.8 was too big, and 3.75 was also too big. Now, if my answer was sitting somewhere here, and I only wanted to round to 1 decimal place, it doesn't actually matter where it's sitting here, because as long as it's bigger than 3.75, it will round to 3.8. However, if it's sitting over here, somewhere in this side here, it also doesn't matter where it's sitting, because any number in here is going to round to 3.7. Because if you pick any number, 3.71, that rounds to 3.7, 3.73 rounds to 3.7, any number here will round down to 3.7, and any number here will round up to 3.8. So if this number is too big, that tells me that it has to be on that side. And it doesn't matter, as I said, where on that side, because they will all round to 3.7. So my limit here, my to 1 decimal place, has told me that even though 3.75 is too big, I don't have to continue trialing it, because it is too big, I know that my answer will sit on that side. So I can say that x is going to be equal to 3.7 to 1 decimal place. Right? And as I said, the root of 14 is actually 3.74165, and if I rounded that to 1 decimal place, it would be 3.7. Alright, so that's the basis of trial and improvement. I'm going to do the next one a little quicker, and I'm not going to just have a basic x squared, I'm going to actually make it an equation. Alright, so we'll keep the same headings, and we'll do one more of these. Right, so this time my question is x squared plus 2x equals 10. Alright. Now, that's totally fine, because all I actually have to do for this is exactly the same thing. Alright, your layout is incredibly important. Your layout is what will get you your marks. Right? You have to pay attention to this layout. You can't do it any other way, or else you won't get the marks. So, my first trial I'm going to make is going to be 2. 2 squared plus 2 times 2. Right? 2 squared is 4 plus 4, that's going to give me 8. Next, I'm going to trial 3. 3 squared plus 2 times 3. 3 squared is 9 plus 2 times 3, which is 6. 9 plus 6 is 15. Alright. So 8 is obviously too small, and 15 is too big. There's going to be somewhere between 2 and 3. So again, I do a bit of intelligent guesswork. I'm just going to do 2.4. Right? And if I 2.4 squared plus 2 times 2.4 gives me 10.56. And 10.56 is too big. So we go one lower, 2.3. And again, this is to 1 decimal place. So I'm looking to establish my boundaries here. So 2.3, if I do that, I end up with 9.89, and that is too small. Right? I know I'm just putting in the answers here. It's fine, you can actually do that. You can do your working elsewhere. But my goal here, again, is or what I'm actually doing is I'm squaring 2.4 and then multiplying it by 2 and adding those answers together. Right? However you want to do that, it's up to you. So now what I've done is, because I'm going to 1 decimal place, my answer is either going to be 2.4 or it's going to be 2.3. Right? So 2.4 or 2.3. But I know 2.3 is too small and 2.4 is too big. So I need to know what 2.35 is going to be, because that's halfway. And again then, if it sits on this side here, that's going to be, it doesn't matter where on that side it'll sit, because it'll round to 2.4. And if it sits on this side here, my answer, it will round to 2.3. Right, so let's have a look at that. If I trial this middle bit, 2.35, so I do 2.35 squared plus 2 times 2.35, I end up with 10.22. 10.22 is too big. Okay, so that's too big, which means it sits on this side here. It must do, because if that's too big, then that'll be too big, that'll be too big, that'll be too big, any number here will be too big, it must be on that side, so therefore x equals 2.3 to 1 decimal place. Right, a quick mention on the marks here. Right, your marks come in for finding this. Okay, establishing your boundaries. Right, establishing those boundaries. Your marks come in for that. 2.35, establishing this middle bit, so you must trial 2.35. I don't care if 2.4 gave me 10.0001. Right? Obviously then it's going to be closest to 2.4, because that will be where it is. I still have to trial the number in the middle, because that's where my marks are. That's where I'm making sure I'm improving. Right? I'm not guessing. At no point is it a guess. It's mathematical certainty. I'm certain that to 1 decimal place, x will equal 2.3. I know that. Right? So you have to trial that, and then you have to state this at the end. You have to give a conclusion to your trial and improvement. And if it's worth 4 marks, there'll usually be a mark in here for your comments. Okay? There's questions either worth 3 or 4 marks, depending on how generous the mark scheme is. Right, so you need to be doing that. That doesn't mean you can leave out everything else, because the layout, if it's wrong, you won't get this. You won't get the nice smoothness that these questions kind of give you. All right, so I've got a question for you to try at home. Have a go with it. It's similar to this one that we see on the board. There we go. Have a go with that. Please remember to lay it out, trial, working, and then your comment. All right, have a go with that. Pause the video. Alright, and if you have paused that video, here we go, the answers to that. And please note the trials down here. It doesn't matter how many trials you do. Right? I happen to jump straight to 4.9 or 4.8. If you had to do 4.5, 4.6, 4.7, and then 4.8 or 4.9 first, that's okay. It doesn't make a difference, right? Try them all. You know, try as many or as few as you need to. Be intelligent about it, but try them. Okay? You get a mark here for establishing the boundary. Get another mark here. Again, here, look, I try to put in as much working, but eventually I just put the answer down. That's okay. Alright? And again, make sure you're commenting every time. And then draw this little diagram out. Strictly, you don't have to draw the diagram out. You just have to provide the conclusion. But the diagram does help. Alright, so hope that makes sense to you. I hope trial and improvement is a little bit easier for you. If not, please have a look on YouTube, find another video, have a look at that, see if they explain it in a different way. Perhaps ask your friends, ask your maths teacher, have a look on Khan Academy, great with these sorts of things. But that's it for me. Yeah, I'll see you for my next video. Cheers.